Another important part of hypothesis testing is something called a significance level. So we need to make sure that we are being accurate according to the correct significance level. So there are 3 significance levels listed here. Our significance level, we use the letter alpha, and alpha tells us how accurate we need to be. Okay, if alpha were equal to 0.10, that means that we use this for matters that are important but are of least importance. So maybe when deciding on a color of a shirt to wear, where life and death is not an issue. If alpha were equal to 0.05, that is used for most applications. So it's of medium importance. And then finally we have an alpha of 0.01, and those are for most important issues. So drugs, treatments, life or death type questions. And we can use these alpha levels and do hypothesis testing for any type of situation. So we have done z-scores, we've done t-distributions, and we've done chi-square distributions. So these alpha levels work for all 3, and hypothesis testing works for all 3 also. And I'll show you where the alpha level comes into play when we get to an actual example for testing. The next important term is called a p-value. So when we have a distribution and we shade in that portion, that is our percent. That's actually what the p-value is. The p-value is the proportion that we're trying to show is unusual. And that p-value is going to, again, show up in all sorts of testing, whether it's a mean, whether it's a proportion, or whether it's a variance or standard deviation. Okay, so p-value is equal to that probability. We just call it p-value in statistics from now on. There are 3 types of hypothesis tests. There is a left-tailed test where that p-value is on the left side of the distribution. So this is what the null hypothesis and alternate hypothesis would look like in this case, where the left tail is the alternate hypothesis. There could be a right-tailed test where the alternate hypothesis is that mu, or the proportion, or the variance is greater than some number, so the p-value would be on the right. Or you could have a two-tailed test. That's when you have the not equal sign, where the p-value, half of it is on the left and half is on the right. Okay, so now let's do an example. For each one of these claims, we want to state the null hypothesis and the alternate hypothesis in words and symbols, and then determine whether it's a left-tailed, right-tailed, or two-tailed test, and then sketch the distribution and point to where the p-value is. Okay, so back to our example of the school publicizing that the proportion involved in extracurricular activities of their students is 61%. Remember, we had the null hypothesis where the proportion was equal to 0.61. That means 61% of students are involved in extracurricular activities. The alternate hypothesis, remember, was that in order to prove that false, it has to be not equal to 0.61. So not 61% of students are involved in extracurricular activities. Since this alternate hypothesis has a not equal sign in it, that means it's two-tailed. That means that our distribution is going to have a left tail and a right tail, where this will be 1/2 of the p-value on the left, and this will be 1/2 of the p-value on the right. Back to our car dealership example. Remember, the null hypothesis and the alternate hypothesis were that the mean time for an oil change was less than 15 minutes for the alternate hypothesis, and the mean was greater than or equal to 15 for the null hypothesis. That means, in words, that the mean oil change time was greater than or equal to 15 minutes, and the mean oil change time was less than 15 minutes. This means that this is left-tailed. You always go by the alternate hypothesis. Left-tailed, that means that the p-value is located here. And the last one, a company advertises that the mean life of its furnaces is more than 18 years. Remember, the null hypothesis was that the mu was less than or equal to 18 years. And the alternate was mu was greater than 18 years because that was their claim. They wanted their furnaces to last longer. The mean life was less than or equal to 18 years. The mean life was greater than 18 years. This defines what type of tail it is. This is a right-tailed. That means that this would be the p-value located on the right.